All right, guys. So we're going to go ahead and move kind of on in our trig unit here. So just to kind of recap what we've covered over the past 2 days, we looked at some right angle trig. Day one, we kind of focused on 30, 60, 90s, 45, 45, 90s. Yesterday, we moved into kind of more using our calculator, which, by the way, you can do that on those special right triangles too. But using our calculator to find a side. So just to kind of review what we have done so far, why don't we look over this warm up? So the first one says solve for x. Well, the first two are solve for x, and then you are gonna just find sine, cosine, and tangent on that third triangle. Okay. So I'll do the first one, and then give you guys a minute on the next one. Yes. So, well, let's see. So you can't, because opposite, if you try to opposite over hypotenuse, that would just be 1 every time, right? So no. So yeah, you want to use one of the two other angles. All right, so good question. All right, so let's look at the first one together. They're not really numbered, but kind of trying to find x, which is here. And what else we're given is well, we're given that this is 4, and then we're given both of the other angles. So there's a couple ways we could go. Okay, the easiest way would be if you can remember it. This is one of our special right triangles, and we are given the short leg, and we are asked to find the hypotenuse. Does anybody just happen to remember the proportion between the short leg and the hypotenuse of a 30, 60, 90? It's 2 times. That's right. It's 1 to 2. Okay. So if this is kind of x, as we call it, then this side would be 2x. So we could simply, if we remember that, just double 4, right? So so in that case, using that logic, x would be 8. So that's nice if you can remember it. We don't always remember that shortcut. So we could, another approach would be set up a trig ratio, right? So you could, as an example, you could just say, so like sine of 30 equals 4 over x. And then in your calculator, you could say, or just type 4 divided by sine of 30. That's also one of those things that you'll be asked to remember. Sine of 30 is 1/2. But anyways, 4 divided by 1/2 would give you 8 as well. All right, so one way or the other, you try to solve for x on the next one. It's kind of confusing, but that's all the way across there. And then find sine, cosine, and tangent. So in case you don't know, maybe one of my geometry students, what kind of triangle is the second triangle? Yeah, 45, 45, 90. And we know that's true because if the legs are congruent, then that implies it's a 45, 45, 90. All right, so take a second here and just try to do what you can on finding x. And then the easy example would be sine, cosine, and tangent for that third triangle. I'll give you like a minute or so to get ahead of me here. All right, so if you don't have the second one figured out, go ahead and just try to list out sine, cosine, and tangent for the other one, just to kind of, hopefully you're getting a little bit quicker on those, maybe going away from SOHCAHTOA and just kind of being more reflexive about it, knowing your ratios kind of without thinking about them. All right, so let's go ahead and talk about these. Anybody want to volunteer and answer for x in the middle problem? Anybody think they have it? Yeah. Okay, so that may be right. Let's see. So yeah, so as a decimal, that would be correct. So let's see how we could get that maybe a couple ways. Okay, so I can tell you that you know, you use the trig ratio if you got a decimal. Okay, if we wanted an exact value, the easiest way to come up with that would be use our proportions. Okay, this is a 45, 45, 90. So we say legs are the same, or we could call them x. And then hypotenuse related to the leg is it's x times the square root of 2, or x square roots of 2. Okay, so if we're just kind of doing you know, kind of using our logic here to get from 16 you know, to x, we just need to divide by the square root of 2. So we could set it up as 16 divided by the square root of 2, and then just work on simplifying from there. Again, if we just type that in, it's going to give me that 11.31 number. Okay, but if we want an exact value there, remember how to do that too. This would be equal to 16 square roots of 2 over 2, which is 8 square roots of 2. Or again, like Ryan had, about 11.31. All right. So again, think about how you might use your calculator to get that 11.31 number too. Okay, because there is another way. All right. So then on the last one, I want you to just say it if you know it. So sine is what? Come on, somebody knows it. 3 over 5. All right. Cosine is 4 over 5. Thank you. And tangent. All right. So if we only have one participant, I guess I gotta give you something. Probably embarrass you a little bit, but it's worth the Jolly Rancher. Is that Haley? Thanks. All you other people are losers. Just kidding. Just kidding. Well, at least I participate. All right. So we're gonna go ahead and go through some definitions and then kind of get into these angles of rotation. Okay. All right. So an angle is what is in what we call standard position. This is pretty much how we deal with angles in standard position. When its vertex is at the origin and one ray is on the x-axis. Okay. Then we say the ray on the x-axis is called the, that's kind of our starting point. So we call that the initial side. Initial side, or starting point, to put it kind of more simply. The ray that rotates is called the terminal side. So where it starts and where it ends. The blank is found by rotating the terminal side and keeping the initial side in place. That is the title of the notes. That's called the angle of rotation. And this last part's kind of important. It says when the terminal side is rotated counterclockwise, the angle of rotation is positive, is the word there. And if it goes clockwise, it's negative. So lots of information there. Let's diagram out some of it. There's not room to show kind of all this, but we'll show some examples of at least kind of maybe a positive rotation, right? So let's kind of draw a ray like right here. Okay, and we're gonna say so this is our angle of rotation starting here and rotating to the right. Okay, so let's go ahead and label some of this. All right, so our initial side in this case, like, is the x-axis. Our terminal side is the ray that we drew. And you know, this would be an example of a positive rotation. Okay. So let's look more specifically at that idea of a positive and a negative rotation. Okay. So again, positive rotations go counterclockwise. So I always kind of remember that like I remember the quadrants, right? So we have quad 1, quad 2, quad 3, quad 4. Kind of think about where those go and how we number them counterclockwise, right? So let's do just an example here. So let's say, let's see what I put on the notes. Let's draw another ray kind of similar to what we did on the other one. Something like that. And so say we want to say how many degrees of a rotation would that be? First of all, it's positive because it goes in that counterclockwise direction. Here's kind of how you think about, you kind of break it down into almost like quadrants, right? So we think this is our starting point, so that's 0 degrees. A quarter of a turn is 90 degrees. Half is 180. 3/4 is 270, right? So we're just counting in multiples of 90, basically. And then when we get back to 0, if we go all the way around, that's called 360. All right, so you know, I can see that my angle of rotation here is past 90 and not quite to 180, closer to 90. So we could say maybe this is about, anybody want to estimate? 100, probably a little more than 100, maybe. 100 wouldn't be a bad guess. I was going for 120 there, so 100, 110, 120, somewhere in there. Okay, any of those would be good guesses, right? We're not going to be exact when we do this, but past 90, less than 180, closer to 90 than 180. Okay, all right. So then a negative rotation. Okay, so this time we would say, okay, this is still 0. And then negative 90 is where 270 is. Okay, negative 180 is where 180 is, because half a turn's half a turn either way. And then negative 270 is where positive 90 was. Okay, and we can call it 0 and 360, or we could call it 0 and negative 360. All right, so let's just look to see maybe let's draw that same ray here and see what that would be as, say, a negative rotation. Okay, so if we start at the same place and we rotate the other direction, what would that be? So in this case, again, we're going to pretend those rays are the same. Obviously, again, there's some error there, but we'll pretend that the positive would be a 120. So what would it be the other way around? So somewhere between negative 180 and negative 270. If it's the same ray as the last time, anybody know what exactly it would be? Negative what? It'd be negative 240. Negative 240. Okay. So I think. So yeah, if you kind of added 240 and 120, we'd get what? 360, right? So that would be kind of the thought process there. Anyways, let's go ahead and draw a couple on our own, and we're just going to do a couple. Actually, we'll do 3 of them. All right, so trying to draw A. Again, we want to think about 300, right? So we're going to go counterclockwise first of all. We're going to need to go between 270 and 360. All right, and then am I going to be a little closer to 270 or a little closer to 360? A little closer to 270. So I'm 30 degrees past 270. Okay, so I want to just kind of keep going around and get about, you know, wherever you think 30 degrees past would be. And we'll just kind of draw our ray. So that would be 60 degrees shy of a full rotation, right? And that's how we can diagram that. Okay. All right. So on a negative one, example B, we're just going to go the other way. Okay. So think about what benchmarks are we in between. That'd be in between negative 90 and negative 180. All right, and which one am I going to be closer to in this case? Which of the two benchmarks, negative 90 or negative 180? Andrew?
180.
180, good. Okay. So, sorry, I did that wrong, didn't I? Yes, it would be. Sorry, I'm trying to screw you guys up. Negative 90 would be here. I was going the wrong way. I'm sorry. Yeah, just messing up here. All right, so still, though, closer to negative 180, okay? Just going the other way. All right, so you're kind of thinking 30 degrees shy of negative 180. All right. Okay, so then what about these bigger ones that go over 360? Okay, so on this you want to kind of think about it in almost like a mixed number. Okay, yes, yeah. Sorry about that. No, you're good. You're good. You're good. Yeah, I am going a little quick on these, so if you guys want to go back and see anything, just let me know, please. All right. Okay, so moving on to think about 750. Okay, so let's see, what's my closest multiple of 360 that goes into 750 without going over? Two of them, right? Which is 720. Okay, so we go 720 and whatever is left over. So what would we have left over? 30. Good. All right, so it's kind of two thoughts, right? 720 says go 2 times around. So here's how you would show that part. Almost like a spiral. So there's 1, there's 2, and then you might pause there and then just think, okay, we need to go 30 more. Okay, so that'd just be just a little bit more. And that would have the same ray as a 30-degree angle, right? Or a negative, 330, right? So a lot of these angles share the same ray. Anyways, we'll skip D, but if you want to kind of think about how you would do that, that would be fine. And let's keep moving, though. All right. Mike's still working. We're good. So blank are angles in standard position that have the same terminal side. Those are called coterminal angles. Coterminal. And then if you guys want to use this symbol, you can. That's a good symbol to know, so I'll use that instead of writing the word angles, that little bent L. All right, so each terminal side has infinitely many coterminal angles. So let me give you a visual on a couple of examples. So one example that I put was, so made a ray kind of halfway in between these two. All right, and we could call that about 225. Or if we went the other way, we could call that negative 90 there and then 45 more, so negative 135. So we could say 225 and negative 135 are coterminal angles. Okay, so that's one way you could think about it. Another way you could think about it is, what if they were both positive? So say we draw this ray right here. So we could make one angle, say 30, and then we could make another angle. We could just go around and do 30 more, right? So we could make the other one. So what would that purple one be? How many degrees would that be? 390. And just given that we could rotate as many times as we wanted to, that kind of by definition almost shows you that it says it right there. There are infinitely many coterminal angles. Okay. Yes.
Can you just say 390 or 360?
390. I went 30 past 360.
Okay.
All right. All right. So how do we find coterminal angles? We just add or subtract multiples of 360, okay? So like a test question might say something like the following example. Find the measure of a positive angle and a negative angle that are coterminal with each of the given, okay? So here's kind of what you do, okay? You could go 40 minus 360. It says add or subtract multiples of 360. That gives me a negative number, so negative 320. All right, and then also I could take 40 and add 360. So that's going to be 400. All right, so again, if I could quickly diagram that if I wanted to. I'm not going to diagram another one, but draw about like a, close to a 45-degree angle. So something like that. And you could quickly diagram your negative 320. We'll do that in blue. Would be not quite a full turn in that direction. And then your positive 400 would be over 360 going in the other direction, right? So that would be more like that, right? Again, I'm not going to keep diagramming these, but I think you probably get the picture there. Okay, how they have the same terminal side. Okay, number 2, you might struggle with a little bit more if I told you to find the negative one, because, well, what's 380 minus 360? 20, right? That's positive, so we could use that as our positive coterminal angle. So we'll say and 20. But what about a negative one? How could I get a negative one? Any thoughts? What if I did 20 minus 360? Would that work? That would work, right? So you just basically keep going, okay? So again, on this one, you guys have enough number sense to know 380 minus 360 is not going to be negative, so you could just go 380 minus 360, say, times 2, right? So that's going to give me a negative 340. And if I wanted another negative, I'd subtract another 360, right? You could just keep going on and on and on and on forever, okay? All right, so we are going to finish up real quick with reference angles, and actually we'll do this tomorrow. Let's do this tomorrow, okay? You guys are already packing up on me, so we'll call it a day there. And guys, I'm just going to do this just for the video, so you can ignore me or watch, but the mic's still working, so I might as well get it now. But I'll cover this tomorrow in class. All right, so for an angle that is in standard position, the reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. Okay, so for this one, this is going to be more visual. You do need to draw out the theta and then go from there. Okay, so 150 is going to be between 90 and 180, a little bit closer to 180. So we'll call it about right there. Okay, so once I can see my 150, then I just go by the kind of definition, right? So it says it's a positive acute angle formed by the terminal side and the x-axis, right? So sometimes you have to rotate toward the x-axis, sometimes you have to rotate away from. In this case, to be positive, we would keep rotating in the same direction. So then you kind of think, I was 30 degrees shy of 180 when I did 150, so that's a 30-degree angle. That's my reference angle. Okay, another example, negative 130. You guys have a great day. Is between negative 90 and negative 180. Just slightly closer to negative 90. So in this case, to make it a positive acute angle, I'm going to rotate from the x-axis. Maddie, sorry, I forgot to give you your heads up. Were you able to save it? Okay. And so when do you want to plan on finishing? You want to do it tomorrow in class, or you want to come in during flex today? Okay. You want me to unschedule you? Will she be okay with that? Okay. I'll unschedule you, and then you can schedule it in. I'll do that in just a minute, okay? All right, so in this case, if I rotate down from 180, that's going to be a 50-degree rotation. So my reference angle in this case is 50 degrees. And I knew it was 50 because 130 was 50 short of 180, okay? And then finally, our last example, 280. I know, I'm doing it for the video. It's going to be between 270 and 360. So just barely past 270. We'll call it about right there. All right, so again, thinking about my reference angle, if I want to be positive, I'm going to keep going in that same direction from the reference angle. So I was, let's see, I was 80 degrees short of the full rotation there, so that's going to be an 80-degree reference angle. All right, so that'll conclude our lesson on angles of rotation. Hopefully this helps.